I'm Lily, and today I'll be talking about how privacy heroes need data disguises. This is joint work I did with Malte and Eddie. Many of us have clearly used the HotCrap paper review system. As a diligent reviewer, you send your reviews to the HotCrap database, which stores them associated with your identity. However, imagine the consequences of a data breach, which unblinds all your reviews from conferences that happened years ago and makes them public. What if HotCrap provided a way to set a time limit on your data, and after it expires, disguises your identity and anonymizes your reviews, and even gives you a reveal token so that you could temporarily re-identify yourself to revisit or update your reviews? This would be pretty great. No reviewer would have to worry about their ancient reviews from their PhD years coming back to bite them, and HotCrap would still have all the functionality as before. Beyond policies like this one that preemptively protect your data, HotCrap today is also legally required by laws like the GDPR and CCPA to support user account deletion. Well, unfortunately, it currently falls upon the diligent developer to manually implement these privacy policies, and this is not easy. They must reason about what policies are sufficiently GDPR compliant and protect your privacy. They must find identifying pieces of data and tie these back to particular users, and they must reason about application invariants that cannot be violated. Most of the time, these policies are implemented as ad hoc privacy transformations in application code, but these changes are painful and place a heavy burden on developers because database modifications can be fragile and cause bugs. Even once these issues are resolved, the developer needs to figure out how to support reveal tokens in privacy-preserving ways and to invoke these transformations automatically when the timeout occurs. This is a lot of work that requires complex manual implementation, and as a result, developers today shy away from implementing more flexible and desirable privacy policies in their applications. To help developers become privacy heroes and give people the privacy they deserve, we propose data disguising, a framework that allows developers to systematically reason about privacy transformations. Data disguising aims to lower the developer burden to support legally required privacy policies, such as GDPR user account deletion, and also more nuanced policies such as universal conference anonymization that may, for example, automatically anonymize reviews and even be reversible. Data disguising separates out the reasoning of privacy-preserving data transformations, such as review anonymization, from normal application execution. Developers specify privacy policies as disguises, which they register with a disguising tool that runs alongside the application. These disguises need only be written once, so the developer doesn't need to constantly worry about them and can go back to adding application features. When HotCrap or the reviewer invokes a disguise, potentially registering a time at which the disguise should occur, the disguising tool translates the specification to the physical operations on the application data and performs the disguise. The tool also automatically generates a reveal token, which would allow the reversal of the disguise. To save the token, a user could put it in a vault in third-party storage and encrypt it with the user's key. Then if the user ever wants to come back and look at the reviews, they can unlock their reveal token and give it to HotCrap and the disguising tool to reverse their disguise. Disguise specifications build on the key observation that most desirable privacy transformations rely on three basic transformation operations, namely the decorrelation, modification, and removal of objects. Decorrelation of an object, such as the review, removes references from the object to its owner. The reviews still hang around, so in order to keep referential integrity, the disguising tool creates placeholders as the new owners. Modification of an object changes object attributes, for example, columns in a database table, and removal of an object deletes it. These transformations in the disguise specification compared with predicates that specify which objects get disguised. So in total, a disguise specification includes sets of these basic transformation predicate pairs. A disguising tool interprets and applies all the changes of the disguise at once to the application database. To see if data disguising will work in practice, we implemented a preliminary prototype disguising tool called Edna for applications with relational databases, and wrote disguise specifications for Edna that translates to concrete SQL operations. We wrote 3 different hotcrap disguises, one for conference anonymization that anonymizes the data of all users, and 2 different GDPR account deletion policies. Strict account deletion removes all of a user's data objects, including reviews, whereas review-preserving account deletion retains but decorrelates reviews from their owners. The conference anonymization disguise specifies 15 transformation operations, while the 2 account deletion disguises specify 9 and 18 operations respectively. We then ran these disguises unoptimized with our Edna prototype and, unsurprisingly, got some very clearly unoptimized numbers. Universal conference anonymization required 7,000 milliseconds for a database with a couple thousand items, while a PC member's GDPR account deletion required 135 milliseconds. This discrepancy between the 2 disguises makes sense. Edna's performance in general varies linearly with how much data a disguise touches, and a disguise like universal anonymization requires touching all the data in the database. Edna has some clear optimizations to make. Currently, all disguise operations are executed as single sequential queries, and batching and concurrent query execution should improve this. Edna can also preemptively create and cache some disguise actions, such as creating placeholder users, or compute disguise modifications on a shadow copy offline to make disguises less disruptive. Beyond simply getting Edna to work, we also encountered a challenge in disguise composition because the disguises we wrote touch the same data. Applying conference anonymization worked as expected, but when we then wanted to invoke strict account deletion for a user, we noticed a problem. Because conference anonymization decorrelates data from the user, Edna doesn't know which data to remove when the user deletes their account and leaves the data in the database. This is problematic because strict account deletion requires the removal of all the user's data. To address this issue, recall that conference anonymization additionally stores a reveal token for the user, with information about the data destroyed while decorrelating their data. This reveal token allows Edna to temporarily recorrelate and then properly delete the user's data. While this is a specific solution that works in this scenario, a general solution for disguises that may interact or may not store reveal tokens at all is still an open question. We also see deployment of vaults as an exciting research area to explore. As we saw, these help support entirely reversible disguises and may be helpful for disguise composition. Edna currently has per-user vaults that store reveal tokens when applying a disguise to one or more users. For example, universal conference anonymization stores tokens in each vault. To be GDPR compliant, vaults should be per user and stored externally and potentially encrypted with per user keys. However, we have a problem here because hotcrap may have hundreds or thousands of users, and a disguise like universal conference anonymization must insert into every one of these vaults. And then to undo this universal disguise, Edna must ask each user for their vault key and query each of these vaults. So while this design may work for a single user disguises like account deletion, this clearly will not scale for universal disguises. One potential solution is for Edna to have 2 tiers of vaults, one global tier for universal disguises, but that provides less privacy for individuals, and one per user tier that provides stricter privacy for users. Our prototype data disguising framework and Edna still have far to go to achieve general solutions to these challenges of disguise composition and practical solutions for vaults. In addition, we must address how disguises can minimally affect application performance, and how concurrent application updates and disguise application or reversal should interact. Our preliminary work with Edna has convinced us that data disguising can reduce the developer burden required to implement better privacy for users in web applications. It does so by providing a framework for systematic privacy specifications in the form of disguises, which can express a number of flexible privacy policies and separates privacy handling code from application code. Data disguising also allows us to reason about disguised behavior in structured ways. However, data disguising at present is far from being solved. We need to answer some important questions, namely how disguises affect application performance, how disguises interact with each other and with application queries, and what abstractions are needed to communicate application privacy goals. We're excited to tackle the challenges faced in making data disguising a reality, and we look forward to your feedback to help us in our journey to make developers privacy heroes. Thank you.